First of all, I want to welcome you to Google Next 2021. In this session, I will focus on what role integrated observability tools play in helping development teams become elite performing teams. So, without further delay, let's get started. My name is Rakesh Dhoopar. I'm a director of product management at Google. I focus on our products related to cloud observability. In today's session, I will touch on five areas. First, I will start by talking about what do we mean by the term elite performing teams. While transformation towards becoming an elite team usually requires a wide variety of changes, including adhering to certain operational principles, evolving operational processes, and adopting a variety of tools, in this session, I will focus on observability tools only. We call our offering for observability the Cloud Ops Suite. I will then dive deeper into some of the specific capabilities that help developers and operators reduce the time they need to spend on identifying, diagnosing, and troubleshooting problems. Now, this part of the talk will focus on how we make it easier to instrument and collect telemetry signals and analyze them effectively to improve troubleshooting. Lastly, I will talk about how developers and operators can overcome friction between the two teams so that they can move fast while maintaining reliability of their services. So let me first start by defining what we mean by the term elite teams. And to illustrate that, I will refer to a quote from the DORA report. So some of you may be wondering, what is the DORA report? Now, at its very foundation, DORA is an ongoing research program sponsored by Google. It is the largest and longest running research program of its kind. The research program collects and analyzes data from over 30,000 practitioners and analyzes the practices that drive their software delivery and operations performance. Participating organizations are measured on metrics for software development, metrics for software deployment, and metrics for service operations. From this collected data, we then do cluster analysis to benchmark organizations against the industry and identify characteristics that are grouped into cohorts for low, medium, high, and elite performers. Elite teams are the highest performers on at least one of the metrics measured for either software development, software deployment, or service operations. Now, one of the most interesting findings from this research is that many professionals approach these metrics as representing a set of trade offs. Now, these professionals believe that increasing throughput of software development will negatively impact the availability and reliability of their services. However, to the contrary, this research has consistently shown for the last 6 years that speed and stability are outcomes that enable each other. Simply stated, elite performers are able to move fast and deploy their code rapidly without compromising on service reliability. The research also found that elite teams were able to deploy multiple times a day, while low performers were deploying less than once per month. Now, at the same time, these elite performers had a time to restore a service of less than 1 hour, while the low performers reported between 1 week to 1 month. I'm going to briefly talk about one of our customers in more detail, and that customer is Lowe's. So Lowe's is one of the largest do-it-yourself home improvement retailer in the United States. Now, as a part of their digital transformation efforts, they decided to modernize some of their applications using Google Cloud. Now, as they went through this business transformation, they worked closely with Google to transform their organization from a traditional IT ops organization to an SRE type organization. For their observability tools, they picked our cloud native capabilities offered by the Cloud Operations Suite. While they embarked on this journey in 2019, in early 2020, they had to accelerate this transformation effort. The pandemic forced more and more customers to transact online, and they had to integrate these cloud native apps with pricing systems that were running on prem and with many store based inventory systems so that they could fulfill customer orders from a particular store in a timely manner. Then, during the Black Friday Cyber Monday period, their transaction volume increased by 3 times of their already high daily volume. Lowe's handled the entire workload and their observability challenges without any hiccups. The results they shared with us were simply amazing. They were able to reduce their mean time to acknowledge from 30 minutes to 1 minute, their mean time to restore a service from 2 hours to 20 minutes, while increasing their development velocity by 300x. They were able to move from one monolithic release every 2 weeks to 20 plus releases a day. Now that's quite a story. So let's dive into the observability tools offering from Google. Collectively, we call these capabilities Cloud Operations Suite. Cloud Operations Suite is Google's observability solution that was designed for scale. It includes cloud monitoring, cloud logging, and advanced observability tools. Cloud monitoring captures and analyzes system and application metrics. It also enables users to define and monitor service level objectives, and it automatically tracks corresponding error budgets. Cloud logging offers users the ability to aggregate system and application logs and explore these logs with an intuitive Log Explorer UI. Our advanced observability tools include CloudTrace, and that enables users to track how requests are propagating through your applications or microservices and receive detailed real-time insights. Now, it is important to highlight that cloud logging and monitoring are both built on the same platform that Google uses internally for its SRE operations. Now, as a result, as your applications scale, you don't have to worry about scaling your observability tools. Google Cloud Logging processes about 2.5 exabytes of log data every month. Now, while most enterprises may not require that level of scalability, you should feel comfortable that the logging and monitoring systems will be able to scale not if, but when your business needs suddenly change and you witness an order of magnitude more users or are faced with any kind of cloud burst use cases. And that has actually happened with several of our customers, and I will share a couple of examples here. Gannett, a media company that owns USA Today, they saw an order of magnitude higher number of users on election night 2020 in the US. In another example, one of our gaming customers saw their users expand overnight every time they launched new games. So they have easily seen more than 1 million users join over a very short period of time. And in both cases, the customers were able to scale their applications and along with those applications, their observability solutions. Similarly, our monitoring service is also based on a highly scalable time series platform. When applications were monolithic and deployed on a small number of named servers, the volume of metrics in monitoring tools was not very high. Now, with the move to Kubernetes and microservices-based architectures, the number of components generating metrics has gone way up. In some instances, we have seen that metric volumes have actually gone up by almost 100 times. Also, because of the ephemeral nature of components, the granularity of metrics has shifted from 1 minute collection frequency down to 10-second collection frequency, and sometimes even down to 1 second collection frequency. All of these have created extremely high requirements on scaling the underlying time series platforms. And we want to make sure that we provide a platform that scales to meet your toughest scaling requirements. So with that high-level overview, let us first look at how users can instrument their applications and collect telemetry signals from systems and applications that are running on GCP. Instrumentation and data collection have always been a challenge in IT, and we have seen a proliferation of agents over the past 2 decades. Google has been a strong proponent of open standards, and we've been actively driving open telemetry standard for service instrumentation and signal collection. Now, as the standards evolve and mature, we have been adopting it in our products to make it easier for developers to instrument their applications. The OpenTelemetry standard consists of three key things. A, language-specific API and SDK for developers to instrument their applications. B, the OpenTelemetry collector and receivers for collecting signals. And C, the OpenTelemetry exporter for sending data to different vendors for storage, visualization, and alerting. We're currently working on instrumenting our client libraries with OpenTelemetry, starting with the gRPC library. We believe that as the OpenTelemetry standards mature across all three signal types, it will provide huge benefits for developers to start instrumenting their applications from the very beginning rather than wait for incidents to happen and then have the operations team define what needs to be instrumented in the application. Secondly, to provide out-of-the-box support for OpenTelemetry, we recently released the Unified Ops Agent. The Unified Ops Agent makes it easier to install, configure, and upgrade the collection agent. This unified agent combines the monitoring and logging agent into one installable component and provides a single YAML-based configuration language. We're migrating our third-party application stack monitoring plugins to become OpenTelemetry-based receivers, and those should be available through the rest of this year. Now, Prometheus is a very popular open source monitoring service in Kubernetes environments. Now, in the spirit of openness and support for open source, we support and integrate with Prometheus in two ways. First, we have integrations with the Prometheus engine to make it easier for users to ingest Kubernetes metrics and workload metrics from Prometheus to cloud monitoring and leverage the rich capabilities in cloud monitoring that includes alerting, dashboarding, and metric query language. Second, we recently announced the Google Managed Prometheus service for users who want to continue using Prometheus but do not want to stand up the infrastructure behind Prometheus on their own and then manage the Prometheus service. Now, for GKE environments specifically, we have made signal collection even easier. One of the key benefits of CloudOps is that users do not have to deploy any agents for collecting metrics and logs in GKE environments. Not only does this reduce the toil of deploying agents, this is very critical in Kubernetes environments because the containers are ephemeral, and in some cases, the containers may have very short lifespans as they are automatically scaled up and down based on policies. This automatic collection includes key metrics for a variety of GKE objects, including nodes, pods, and clusters. In addition to the system logs, application logs that are written with standard out and standard error are automatically collected as well. Now, more importantly, the pre-configured agent automatically captures metadata and the hierarchical relationships amongst all of the Kubernetes objects, from clusters to nodes to services, all the way to pods and containers. As we will see later, these relationships come in very handy when users are exploring observability data for diagnosing problems. Let us now briefly look at what capabilities we provide for signal analysis and visualization. As part of the CloudOps suite, we offer an out-of-the-box GKE dashboard. The dashboard provides a very rich and powerful experience that was purpose-built for GKE. The dashboard aggregates all metrics, logs, service-level objectives, Kubernetes events, and alerts into one place for all of your GKE clusters. Entities and their data presented in this dashboard are related to each other using the context graph that I talked about on the previous slide. While the context graph is not visible in the UI, when you start filtering data in this dashboard, the presence of the context graph becomes evident. The filtering is not just a text or label-based filtering, but the filtering in this dashboard happens based on the relationships in the context graph. So, for example, when users filter for a specific cluster, only objects that belong to that cluster will be shown in the dashboard. Each section of the dashboard, from namespace to node to service, will be filtered based on whether or not they belong to the specific cluster. Similarly, when a user filters based on the name of a pod, again, all the objects that are not related to this pod will be filtered out. Only the cluster, the namespace, the node, and the service that this pod belongs to will be shown in the dashboard. Now, this is extremely powerful, and a lot of work has actually gone into scaling this kind of filtering and presenting all of this data in an aggregated manner. Cloud Operations offers purpose-built explorers for each of the three different types of signals, namely metrics, logs, and traces. So for metrics, we offer the Metrics Explorer for analyzing time series data, for creating charts, as well as for adding these charts to a dashboard. For advanced metric analysis, we offer the metric query language, which provides a powerful query-based mechanism to manipulate this time series data. Using these queries, users can compute ratios of metrics, users can perform time shift analysis, users can analyze arbitrary percentiles, and users can evaluate arbitrary mathematical expressions on this time series data. Similarly, the Logs Explorer was purpose-built for analyzing logs. The Logs Explorer provides a histogram view that helps users analyze log trends. Writing log analysis queries can be tedious. So we've made it a lot easier to create, save, and share queries for analyzing these logs. For richer analysis of log data, users can extract and analyze fields from log data, as well as define streaming alerts on individual log events. Logs can also be converted into metrics, and then users can leverage all of the capabilities available in cloud monitoring, which includes visualization, alerting, dashboarding, or defining SLOs on these logs-based metrics. Lastly, the Trace Explorer provides an interface that makes it easy to visualize all traces and associated latencies, filter traces of interest based on different criteria, and define alerts on trace data so that users can do behavioral comparison of how the latency of a specific trace compares over time. While GKE Dashboard provides a curated and tailored experience for GKE-based apps, many customers still need to build custom dashboards. We did quite an extensive amount of UX research over the past year to understand what users need when they're actually creating these dashboards. Based on that research, we have created a pretty intuitive experience for creating and editing custom dashboards. There's a variety of new chart types, dynamically resizable charts, easy way to drag and drop editing on a dashboard, as well as use the full power of the metrics query language within the dashboard itself to explore the data before you add it to a dashboard. Now, one of the interesting chart types we've added recently is the alert chart type. When a user adds this chart to the dashboard, they can also associate an alert policy with that chart, and users can then see the alert threshold from that policy on this chart. Finally, to automate the creation of dashboards, we have populated a GitHub repository with over 60 dashboard templates and a Terraform module to automate the deployment of these templates. In addition, we recently added a sample dashboard capability directly into the product UI that makes it easy to ingest and adapt these sample dashboards from the GitHub repository. Users can get a preview of each of these dashboards without any effort before they start adapting and adopting these sample dashboards. Let us finally look at how development teams can become elite performing teams. And the most important thing we will discuss in this section is how the two teams can collaborate amongst each other. While the collaboration between development and ops teams can be improved by defining and measuring service level objectives, that is easier said than done. To improve that collaboration, we recommend that both developers and operators have a seat at the design table early on in the software design process, so they can agree to a common language, agree on a best way to measure reliability, and create reliability as a shared objective for the two teams. Now, once they have agreed to the service level indicators and what service level objectives they want to achieve, they can then use these capabilities within the service monitoring feature in cloud operations. Cloud monitoring or service monitoring will automatically and continuously keep track of how the teams are doing with respect to the agreed SLO. The error budget is automatically computed and tracked as well. Now, as long as the error budget for a given time period has not been exhausted, developers can move with full velocity to continue pushing out new capabilities. However, as the error budget gets close to exhaustion, the mechanism becomes self regulating, new features are slowed down, and both developers and operators shift towards improving the service reliability. Now, as organizations improve the collaboration between developers and operators around SLOs, they also need to adopt some best practices that we have shared. These best practices include A, accepting that failure is normal and not striving towards 100% SLO. B, measuring everything, including toil and reliability, and using automation and observability tools to reduce toil so developers and operators can contribute towards feature velocity. Lastly, when an incident does happen, we recommend that the two teams strive towards blameless postmortems and drive service reliability improvements. So let us look at how customers can use service monitoring to adopt and implement some of these SRE principles. The service monitoring capabilities enables users to select a service level indicator and define the service level objectives. Now, once the SLO is defined, cloud monitoring will automatically compute and track error budgets. Users can also define alerts on these error budgets. So, as you reach a critical threshold on your error budgets, alerts will be generated and users will be notified about the exhaustion of the error budget. For GKE services, there is further out of the box integration that makes it easier to define these service level objectives. CloudOps will automatically discover services that are using Istio and ASM deployed on GKE. So when a user defines an SLO for these auto-discovered services, if they choose an availability or latency metric, CloudOps will automatically pick or recommend a metric for to be used as a service level indicator. Now, since some customers choose Prometheus to monitor Kubernetes services, and specifically their apps running on Kubernetes, we also provide out-of-the-box integration for such customers to ingest metrics from Prometheus and be able to define SLIs and SLOs on Prometheus metrics. Of course, users can define custom services or choose any other custom metric to be to use as an SLI and then define an SLO on that metric. So let me summarize some of the key highlights from this talk. First, like we have seen from the analysis in the DORA report and from the customer example I talked about, elite teams can achieve high feature velocity without sacrificing service reliability. Two, from a tools point of view, cloud operations offers integrated capabilities that brings together the three different signals to make it easier to improve MTTR and enable developers and SRE users to focus on increasing code velocity. Three, elite teams use SLIs and SLOs as a mechanism to formalize reliability targets between developers and operators, and customers can use these capabilities within cloud operations. If you're interested in more sessions around this topic or interested in learning about our cloud operations suite, there are three additional sessions listed on this slide, and I welcome you to go watch those. Please enjoy those sessions and other sessions in next 2021. And thank you again for attending this session.